Okay, this video is going to be just a couple of quick examples of some dilution problems. So in a dilution problem, we're going to start with our master formula. That's going to say the molarity of the first liquid, or solution, excuse me, times its volume, plus the molarity of the second solution times its volume is going to equal the final molarity times the final volume. And this is a equation that'll work both for adding solutions of different strength together, and I'll show an example of that, and as far as just taking a solution and diluting it down into a weaker solution, the same equation will work for that. So as an example of the first one, let's see what we would get if we took, say, 150 milliliters of 4 molar sulfuric acid, and we added to it some 300 milliliters of 8 molar sulfuric acid. What would our final solution, what would the strength of our final solution be? So we're going to just kind of go ahead and put these things into our formula. We're going to say the molarity of the first solution is 4 molar, and we have 150 milliliters of it. Now we can leave the volume rate in milliliters as long as all of the volumes agree they can be any unit. And so this V will have to be in milliliters, and that will too. Okay, the second solution has a molarity of 8, and it has a volume of 300. And that's going to equal this final molarity that we're looking for times the final volume. And now for the final volume, what we need to do is assume that these volumes are additive. If I take 100 milliliters of water and I add another 100 milliliters to it, I end up with 200 milliliters. So here I took 150 milliliters and I added 300 milliliters to it. And so I can say that my final solution will have a volume of 450 milliliters. And so here, if I want to just put down a note, I can say that VF equals V1 plus V2. And that can be kind of useful for us. Okay. Now this equation is done. We just have to solve it. So I've got 600 plus 2400 equals 450 milliliters. And so I'm going to end up with 3,000 divided by 450, which I should be able to do in my head, but I am a little slow today. So we're going to depend on the calculator. And we're going to have a molarity at the end of 6.7. And that would be the answer. That would be the final molarity of our solution. Okay. So we can do this same thing now with a dilution problem. And so let's say how much water to take a solution that is, say, 16 molar hydrochloric, and let's say that I've got I'm sorry, 60 more. I'm sorry, I'll do a different problem in just a second. I was kind of going on a little train of thought there. Okay, so how much water to dilute 16 molar hydrochloric if we had 150 milliliters of it and we wanted to dilute that to, say, 4 molar? Okay, and this is going to be the same problem, same sort of problem, same equation. So I've got my molarity as 16 molar for my first solution, and I've got 150 milliliters of it. To that, I'm going to add some water. And now water doesn't have anything dissolved in it, so water has a molarity of 0. So I'm going to say I'm adding some water, molarity of 0, and I'm adding some unknown amount of water, X. That's going to be the answer to my question, that X. But it doesn't really help us being in this term because 0 times anything is 0. So this is going to just kind of drop out. And we're going to end up on this right-hand side with our molarity of 4 for our final. And now we know that our final volume is our volume 1 plus our volume 2. So we have for volume 1, 150, and for volume 2, we have X. Okay, now X is again representing the answer to this problem. How much water did we add to the 150 milliliters we had? So if we go ahead and just do this math, it would be, well, apparently I like 2400s today. And that's going to equal, and now to do this algebra, I'm just going to distribute this 4 inside. So I'm going to say 600 plus 4x. And now it's down to a form you guys are probably comfortable with, where I'd subtract this 600 and get 1800 equals 4x. And then I divide that 1800 by the 4 to leave me with this 450 milliliters of water added. Oops. Okay. So those are a couple dilution problems. I'm going to do one more just because the most common probably dilution problem to actually do in the lab is to say, I need to have, say, 800 milliliters of 3 molar sulfuric acid. And my bottle, my supply in my reagent closet, is going to be made from 18 molar sulfuric acid. That's what I get it from at the laboratory supply company. So this would be a very practical problem if I was prepping some solution for your class for one of your labs, if we were still physically together and doing labs. This is the way that I would do that. This is a problem that I solve personally, well, on a regular basis as a science teacher. And so let's take a look at how to do that. Okay, so I know I want to end up with this. So that's going to be my final. So I want to end up with some 3 molar sulfuric acid, and I want 800 milliliters of it. To that, I'm going to have to take and have some 18 molar sulfuric acid with a quantity I don't know. I don't know how much acid to use. That's what I want to solve for. And I also want to solve for the amount of water. Okay, so I'm going to say, well, I don't know the amount of acid that I need to use. And I also don't know the amount of water. Some water as a molarity is 0, and water's volume is going to be unknown. So I'll call that y. Okay. Doesn't really matter what I call it at this stage because, again, 0 times anything makes that drop out. So the amount of acid I need can be found right here pretty simply. 18x equals 2400. Might as well stick with those 2400s. And so I would need some 133 milliliters of 18 molar sulfuric acid. That's how much acid I would need. But now I have one other question I could ask, which is, well, how much water do I need? Very simple. If we go back to that, our final volume equals our first one plus our second one. Well, I have 800 to end up with. I need 133 of acid, and then I have to solve for how much water. And so this would be 667 milliliters of water is what I would need to add. So if I wanted to make this out of my reagent bottle, I'd use 133 milliliters of acid. I'd use 667 milliliters of water. So those are just 3 quick examples using the dilution formula, both for finding a solution created by mixing solutions of 2 different strengths, along with using just water to dilute an existing solution. If you need more help, please hit me up in office hours.